Okay, question 11. Okay, last question on the paper, so it may have some tricky bits in it, but there are loads of easy marks in this as well. Firstly, we've got to find the discriminant of this f of x. So it's a quadratic equation, and the formula for the discriminant is b squared minus So you're going to do bracket squared minus 4 bracket bracket. Okay, put the correct values in, and you'll have finished off part A. Okay, doesn't ask you to comment on what it means, you're just working out what it is. Then we've got to put it in this form, so we're completing the square, but we're doing one of these completing the square where there's a number in front of the x squared. Okay, so you need to remember how that goes. So you've got 2x squared plus 8x plus 3. Now on the next stage, this 2 you don't like, so we're going to park the 2 outside a dirty big bracket. Okay, we do not try to do any completing the square yet. I don't want to see any squaredy brackets on the next stage. I want to see an x squared. I want to see some number of x's, and I want to see a number, which obviously will come from the 8 and the 3. Okay, but they're obviously, we've taken this 2 outside, so these are smaller numbers here. Then you can go to twice the same dirty bracket, but you can now complete the square. So this bit, this x squared, with some number of x, I want to see a squaredy bracket minus a number. Okay, and this bit at the end, that last term just sits there and is there again at the end of this bracket. So I've got a number here, I've got an x plus or minus something here. Okay, and then we have to multiply by this 2 again. So you're going to have 2 times the squaredy bracket. Okay, don't try and take the 2 inside this bracket because it will go wrong. But then you have to multiply both of these things in your dirty bracket and get multiplied up by the 2. Okay, so don't forget to double those again and simplify them to one number, and that's going to give you the number there. Okay, it's going to be plus or minus something. Okay, and that should be the next 3 marks. So standard stuff, if you know your set pieces, you've already got 5 marks out of this last question. All right. Now for the last part, this is where this is a bit more problem solving-y. We've got a tangent to the curve. We've got the equation of that tangent, though we don't know what c is. And the curve is y equals f of x, and we've got to find out what c is. Now there are 2 completely different ways of going about this, okay, and they both work. So I will take you through both, all right, and whichever one is the one you think you'd most easily think of is the one to do, okay. All right, we've met tangents twice in Core 1. One is the situation where we found the tangent at a particular point. So we'd be using yet again the point and the gradient method. So we'd need a point and we'd need a gradient to set up the tangent. But it's kind of backwards now. We know the answer. We can see here what the gradient's going to be. So the gradient, okay, is a value we already know, but to find the point I have to think, okay, whereabouts on this curve, so here's the curve, where is the gradient, that value that I want? So you start with the gradient, you know what its number is, okay, but then you say, okay, that dy by dx, okay, one of your 3 methods for gradient, but this is not the 2-point method. We've just used the gradient of a straight line, but we now want the gradient of the curve to match that gradient, so it's dy by dx the gradient of a curve. So you get what dy by dx is, and you say, okay, dy by dx at the point I'm interested in must equal the value I need to get the correct gradient for this line. And you solve that and you find an x value, and once you know an x value, you've got the equation of the curve, so you can get the y value. So you can get the point, you can get its x value and its y value, and you can actually set up the equation of the tangent, and then you compare your answer, you look at this, and it should come out as y equals 4x plus something, and the something you get at the end is your c, and you write that down and you've got 5 marks. So that was method 1. Method 2 is, I think slightly more people did it this way. They said, well, look, I've got 2 equations. I've got a line and a curve. So, all right, this is a quadratic curve. This is a straight line. So not many people did the diagram, but we've got a quadratic curve and we've got a line, okay, and one's a tangent to the other. So this kind of point where it is a tangent is a solution to what? It's a solution to simultaneous equations. So I've got a line, I've got a curve. So have I got the equations? Yes, I have. I've got the equation of this line and this curve. Now I don't know the details of this equation, but I can set up an equation to start me solving essentially simultaneous equations. So this chunk here would have to equal this bit here. So setting that up as an equation and rearranging it and getting all the x's on one side and naught on the other side is quite a good way to get, maybe 2 out of these 5 marks. Now what you have to do then is use your theory of equations. So when there's a tangent, okay, we've got this situation. We haven't got this where there'd be 2 solutions. So this line here has 2 points of intersection. We haven't got a line like this that has no points of intersection with the curve. We've got the one where there's just one solution. And of course, because it just touches, it's a repeated solution. So having set up a quadratic equation, remembering this approach, we're solving that simultaneously with this. So these 2 things in the circles equal each other. That's a quadratic equation, and that quadratic equation has repeated roots to get just the one solution. So you look at b squared minus 4ac. You know what that has to equal for repeated roots. You get the a, b and c values for that equation. This c is not the c value. The constant in that equation will be a combination of that 3 and that c. But you set up b squared minus 4ac carefully. You say it equals what it has to equal for repeated roots, and you solve that equation for c, and that's how this last part comes out. So you may want to try experimenting with doing that question both ways. Okay, 2 perfectly good ways to get c. Good luck with that.